Okay, so can you all see my screen?
Yes.
Yes.
So all these tests are the ones which we have just understood theoretically that which test is to be done in what sort of a scenario. So now we'll utilize these 2 hours to do these tests, which are part of the analyze phase. So first test is the correlation test that we are going to do. So we know when my y is continuous and my x is continuous, we do a test called correlation and regression. So there is no prerequisite for doing this sort of a test in terms of normal or not normal. You can do this test anytime, whether your y is continuous and your x is also continuous for correlation. So for that, what I have to do is, so I have this data already, okay. In order to do the correlation test, I will use a Minitab. So I go to stats. Everybody with me? Everybody's back?
Yes.
Okay.
Yes.
I go
Yes.
to I go to
Yeah.
stats. I go to basic stats. I go to correlation. Stats, basic stats, and correlation. My y is continuous and my x is continuous. So friends, we are getting into the hypothesis test now. This is the first test that we are going to perform now, uh, wherein I will be telling you how to interpret that, what is the significance out of it, what decisions are we going to make, and how it's going to help us. Okay, so stats, basic stats, and correlation. Okay, since we know that these are the only two variables that we have which is continuous in nature, so Minitab is not showing anything else at the moment. It is not showing any sort of an attribute or any sort of a discrete data here. So I click HT in seconds, which is my continuous, and hold as well, which is also a discrete data that I have. Okay, I click on OK. So here you see, so if you remember, we did a scatter plot. Okay, what does scatter plot tells me? Does anybody remember that? Scatter plot and correlation does not have major difference.
Scatter plot shows the relation between two variables by depicting the graph between them. It can be positively correlated or negatively correlated related based upon the slope of the graph.
Okay, yeah, absolutely. So basis the slope of the graph, we decide whether uh, both the variables have what sort of a relation. That's what we've learned in this scatter plot. Okay, and these relations could be a positive relation, negative correlation, and no correlation. Okay, positive correlation is when my both variables are moving in the same direction. If one is increasing, another is increasing, means another variable is increasing. And negative correlation is when one variable is increasing, another is decreasing, so it works in the opposite direction. So that's what we learned in the scatter plot. So correlation is similarly the same, it's just that it gives a R value. It's a significant value which we kind of derive out of it, which says that what sort of a relation it has. So here it says, it talks about two things here. Okay, first it says a p-value. Okay, in the older version it still shows the p-value, but in the new version we will not find the p-value here, but it says the Pearson correlation of ht in second and hold. Okay, so that's the Pearson coefficient value, which is also known as the R value. Okay, so this value is minus 0.008. Can you see that?
Yeah.
So minus 0.008, which says that HT and hold has a negative sort of relation. So can I ask a question from anybody? When your y is continuous and your x is also continuous, which means now in this particular case we are taking an example of AHT versus hold time. And now if I've come to know that there is a negative sort of a correlation, which means if my AHT increases, my hold decreases, and if my AHT decreases, my hold increases. You're doing a project.
Sorry to disturb, Simon, but even though it is negative, it is very low correlation. It's almost zero. So
Yes.
we'll take that in mind.
Yeah, so it is very near to very near to zero, and zero means a no correlation. But still, there is a negative value which has come. So, which is kind of a very weak negative correlation, but it's a negative correlation. It's a very weak negative correlation. So my question is to all of you that in this particular scenario, let's say you're doing a project on improving the average handling time, and you got a negative correlation when you compare it with hold. What sort of decision would you be taking? What is that you want to do next? I want to know from you all, and then I will conclude. Let's hear it from you guys.
So, sorry.
Anybody? Ashwini, you want to go first?
Oh, yeah. Okay. So here we can see that there is a negative correlation. So if we want to increase AST in seconds and we can control hold, then we would reduce the hold. But as it is very low correlation, we can say that
Yeah.
we won't get any substantial benefits from changing the hold that very much. So we will
Yeah.
look for some other avenues for improving our bike. Yeah.
Okay. Very good explanation, Ashwini. Anybody else wants to make any conclusion out of it? I'm asking conclusion from all of you so that we can learn it together rather than me telling and moving to the next tool. I want to know from you. So you know which scenario we do this test. We have done it. Now we also know the significance of R value. We have also seen that. I just want to know that what would you do in this case? Anybody wants to try?
So Simar, if my target is to reduce the AHT and if it has a negative correlation, I would not consider hold to be my X any further.
And how did you interpret that?
So technically, when you're running a project, your project would be to reduce the AHT, and if I see a negative correlation here, which technically means that when your AHT is reducing, your hold is increasing.
Mm-hmm.
So it does not give me any inference to go ahead with hold as a X. So that's what my thought is. I might be wrong there.
So in this particular case, there are two things that we're going to look at. Okay, one is the R value, which gives me a uniformity that what sort of a number it is. With the help of an R value, I will decide whether I'll be working on this X or not. So what is the X in this particular example?
It's a hold.
It's a whole time. Okay, so we assume that there is one X which we have identified from the brainstorming, that hold is a significant hold has an impact on HT or not, but I was not pretty sure about it. So that's why I'm doing a hypothesis test to come up with a conclusion whether is there any benefit of working on hold to improve average handling time or not. That is my objective. With the looking at the R value, which is in minus 0.008, which is pretty close to zero, okay, which is pretty close to zero. And when the R value is zero, it means my hold has not a significant impact on my HT. So in this particular case, I will not work on the hold as a cause. I will ignore this and will work on the other cause. Okay. In the same example, if my R value would have been 0.89, okay. So this question is for Ratna. Ratna, if my R value here is 0.89, what sort of decision I would be taking?
It's greater than 0.005.
It's not a p-value, Ratna. It's not a p-value. It's a, I think you missed it. Maybe you joined a little late. We are talking about the Pearson correlation value here, which is the R value, which has come here. Okay.
Okay, it's negative. Okay.
So let's say if it's not negative, let's say R value is 0.89. Okay. 0.89, which is very closer to 1. And we know that if it's closer to 1, it's a strong positive correlation between two variables. So if that is the scenario, what would you do? What would be my strategy? Will I work on this cause? Will I ignore it? What would I do in that case?
It shows that what did you tell about the value? If it is closer to 0, then?
Okay, let me just do it here.
So,
Let her answer. Rahul, let her answer.
Okay,
We'll
okay.
give you an opportunity. Let's one person understand everything, because he or she is making an attempt.